aspect that I would like to bring up is that same period, I don't know, 81 or 82 onwards, I was teaching some MTech students. Our MTech students were Nandita Dasgupta, Amitabh Dasgupta, both of them who are faculty. There was one Rajesh Sanghi, who had come from Air Force. Somehow I got actually quite friendly with them, very friendly with a bunch of them. So it was not just undergraduate with MTech students. Actually, I found, and this is not about individuals, but I did find that master students, and from very early onwards, we are noting that if you put a master students and undergraduate students together in the same class, and I very often used to have, in performance, the undergraduate students will perform far superior than master students. But if you take persistence in trying to do something, if I give a difficult problem which will take multiple days and weeks, you will see our master student doing very well compared to our undergraduate students. This is something that I remember starting to note from 1983 onwards, and probably IIT still does not fully understand that the students who come from other colleges but are willing to work very hard, in long run they are as good and probably better than our undergraduate students. This is something that IIT system did not understand. I started noticing, to me it came as a surprise. And of course I had some very good students and all that. I was at the same time starting to work on various subsystems, particularly after that WS Industries I had delivered that power line carrier communication, and the only person who was building systems in the department for anyone was Professor J.P. Raina in what we later on termed as fiber optics lab. I started taking interest in his work and saw that what he is trying to build is relatively simple. His contacts were huge. He had huge defense contacts. He has contacts in DRDO. He had contacts in Ministry of Electronics. He was a very aggressive person. So he will go and sell them something. But I also noticed that particularly since most of our communication system, he didn't have very good idea how to build it. But that's where I came in. I learned how to build it. So, one of the first projects that Professor Raina and I did together was a very interesting project, and tells you a lot about India. The people from CVRD had come, some defense officers had come, senior people from DRDO, and said that you people are working on optical fiber, and Professor Raina was just starting to work on optical fiber. And he had said what they would like to do was build a fiber optic communication system for a battle tank.
Within the tank, have a network?
Within the tank. A little surprised. We went and visited CVRD, and I found that the inside of the tank, in which 5 people used to sit, was no bigger than this circle. In fact, smaller than this. And everybody would sit with their face outward looking, so they will not see each other. And they said that we want a fiber optic system for them to talk to each other. I said, why? They are just next to each other. They made me go on a ride, and I saw that the tank was making huge noise. The noise was so much that we couldn't talk to each other. So they said only way we could do it using headphones and cables. So that's what they were using. Where did fiber optics come from? You are talking about 1, 2, maybe 3 voice conversation. We used to talk about something which can multiplex 64 voice signals and a lot of data signals. Here they were talking about 3, 4 of this, and maybe a few indicator, somebody will turn, their light will go on. Very little data communication, very little voice communication. And I said, why is it required? There was an interesting story told to us. I don't know whether the story is true, but it's a very interesting story. This is a story about when Pakistan had attacked us with Patton tank. And the Patton tank coming from US was so powerful. The Pakistani army was marching with the tank, and we could not just defend. Anything that will shoot at the tank will just go for a toss, it will not penetrate. The story actually went that till somebody actually figured out that they will put a person who will bend down and kind of hide in bushes, and when the tank will come, he will run down, climb up the tank, open the hood, throw a bomb and run for his life. And he says that's how India battled and won against Pakistan in one of the tank. But what I was told, that things became more complicated even when our tanks were getting deployed, that when nothing else will penetrate, the confusion was created by a electronic gun which will just shoot radio waves, and somehow it will penetrate the tank at some frequency and will create so much of noise in those cables that it will be impossible for people to talk to each other. They will put the headphone down and they will no longer be able to talk to each other. And if they are not talking to each other, gunner is pointing in direction different from what they should point. The driver is taking in one direction, commander is asking you to do something, and there will be chaos. That's a time somebody will run and throw a bomb. And somebody had told them that optical fiber, no electromagnetic wave can penetrate, which we knew, and maybe it can, if you can make that, it will be something that nobody will be able to disturb and communication will be very sound, very good. They challenged us to make a system like this, and I took it upon myself. Said, sure, we'll build a system. So our dream about fiber optics and all this talk was following up that power line carrier communication, which was carrying, multiplexing 11 voice signals on a cable. Here we are able to do hundreds of voice signals on a cable, and here we are actually back down to where bandwidth did not matter, where distance did not matter, and we are going to do this. We took upon ourselves to build a system like this. I don't remember who had funded it, but we built it. And as we were building it, Rajesh Sanghi, who was an MTech student from Air Force, deputed here, he was already becoming close to me, and he started working on this project. And we built this project, and having an Air Force officer and was a huge help, because he will do all the interface with CVRD and with the army officers, and was able to do much better than we could. He would go get it deployed in the tank, test it out, climb, do everything. And the system was doing very well. of course, a tragedy took place. That one day we heard that he was doing this and the tank was running and they were going and they will go through difficult terrain. It was a main battle tank and it was just about being tested, and while doing it the tank overturned. And Rajesh Sanghi got hit, his bone here was broken. Well, he was hospitalized, he was cheerful, he didn't blame us, and for him this is a part of being in the armed forces, air force. You get injured. This will heal, and we did realize that this will heal. But it was also clear that with this small defect that he has in hand, he won't be promoted very high, because there is a rule in these armed forces and air force that up to a certain rank only you can go if you have had some kind of injury which stays permanent. So, those very bright officers did quite well in the exam and courses and did everything, had done the project. What will he do? Meantime, we also saw him as a great asset to our system building effort, that here is a person who would be able to not only translate the defense ideas to us, but be able to also carry it all the way to the inside the defense. And we were now getting contracts from defense. You build this system, build something for aircraft, 1553, 1773 bus, fiber optic system. And we were quite willing to take up these things. We had by this time 30-40 people working with us. I remember we had made 2 megabit per second system, 8 megabit per second system, 34 megabit per second. We are just about getting to build. And we proposed a project. I think it was a Ministry of Electronics plus some defense agency was also there. And we said we will go and build 140 megabit per second. It was state of art. Nobody else in the world was built a 140 megabit per second. And I remember going to the meeting in Delhi. It was at IIT Delhi, making a presentation. He said, there is nothing here that we don't understand. And I had learned how to build multiplexing and everything quite well. And the basic challenge is in actually doing things. So we will fail a few times, but we are better positioned to build this than any other person. If any other person can build it in the country, we will be happy. We are not the. But if nobody else can, we need to. Otherwise, forever we will be dependent, and not only 140 megabit per second, tomorrow 565, everything will be imported. And when I said all this with my passion, they immediately sanctioned Plus project. So we had enough money, we had large money. Fortunately, number of our alumni also were particularly the ones who are very friendly to us. People like Deepak Kanchandani would come back to us. They had joined semiconductor complex. The place closed down, did not do very well. He was lost and he would come back to us and work with us. So we had talent, we had people. We were able to take students from engineering colleges nearby. We are able to take students from engineering colleges nearby. By that time, that had started proliferating, and we are able to train them and do well. But to be able to do some of these things, we wanted Dr. Sanghi to be with us. He says he would love to do his PhD with me. But how does he do that? Air Force will not release him. But we had enough defense project. So I remember we had gone all the way to the scientific officer, I think Abdul Kalam at that time, the DRDO head, and myself and Professor Rana went and said, we can build all these things. We need him to be, he will do his PhD also. Please permit him. And I knew that if you are honest and speaking and were ready to do something, the rules can be bent. And this is what Professor Indiresan used to always teach us. You know, there are these rules, you must understand that. If you go and try to hit against the rules, you will never be able to penetrate them. There is a huge barrier. You have to learn to bend the rules.
Okay, it's interesting that you say it because there is a story I have heard when Professor Paul Raj, again coming from defense, was doing his MTech at IIT Delhi under Professor Indiresan. He saw that Paul Raj was very bright, so he wanted him to continue for PhD, and rules didn't permit, and he somehow got the rules bent so that Paul Raj continues for his PhD and built the sonar. Is what I mean, I don't know if the story is correct, but this is a story I've heard.
Must be correct. Professor Indiresan always taught us. He will always point out, and by the time guidance and counseling unit had happened, I was quite close to him, and as I told you, he tried to teach a course also along with me, and I could reach him, and he was very enthused that I'm just trying to do this. He was fully encouraging us. Let me tell you, the rest of the department was not very friendly to Professor Rana. There was a huge conflict, and since I was working with Professor Rana, they used to also watch me with huge kind of suspicion. But people like Professor Radhakrishna Rao, Professor Vijike Murthy used to know that I am very sincere and used to kind of encourage me. So here we are able to get Dr. Sanghi, and he became one of my early PhD students. Of course, I had one or two other. One person had worked on surface acoustic wave devices. One thing about this, I had done my PhD in surface acoustic wave devices. This is where I could easily do work, publish. I did not need anything except computers. I had my first PhD student, Elizabeth Elias, who did her PhD work with me. Actually, largely it was understanding this and then software programming. But I was bored with that work. And here is a much more interesting work that I was doing, whether I was doing for main battle tank or for the aircraft or for doing things. I got more interested in fiber optics and system development. If you remember, it was in the process of doing this that I made a fiber optic multiplexing kit. I had taught in the United States for 2 years only, and I was teaching here. I knew our students were brighter, but there was one difference. Their labs, they used to learn much more than our labs. Our labs were very boring, routine. There was one instrument that was expensive, and we would only take people and somebody will operate that instrument and they will take reading. There's no fun, very little learning. This is something that I had noticed about labs here. Whereas lab in the United States, where there was some kind of full kit given to each student individually. And a problem will be given to them and they will have to build it. And as saw they were used to do it, we used to give them a week before, they used to prepare for it, come, we'll have a discussion in the beginning, get them going, in the middle of this we'll go around each desk, help them. There's a huge learning for them and for us. Out here the labs had no learning. The students were bored. They used to cut corners. I had been talking to head of department, other senior faculty that why can't we create so many kits, and people sort of said, well, we don't have money. So this kind of inspired me that we can build the kits and make it low cost. And since I had learned enough about multiplexing, a lot of interesting things you can teach about multiplexing, the synchronization, lack of synchronization, bit synchronization, byte synchronization, clock synchronization, failure of that, multiplexing, channel switching, time switching, all of this you could do in a fiber optic kit. And I had got an undergraduate student to work with me to build that kit. And we had commercialized that. I'll talk more about it initially with Universal, then with my benchmark systems. I'll talk more about it. Till today, I'm known in colleges all over the country as a person who had designed that kit. Even today, I get 35 years down the line, we every year get some royalties on that kit. That kit has taught simple multiplexing and communication to very large number of people all over the country. We'll come back to that later on. But what I was pointing out that we were building systems, initially for defense and for Ministry of Electronics, and building complex system and used to employ large number of people. At the same time, the industry was showing some interest. So, while I used to work on this defense project and other projects with Professor Rana, some industries were coming to me personally, and I was in laser communication lab building some of the projects and employing them. There is an interesting thing that I want to point out. It's about India and about Tamil Nadu. In my first year after I came here, very often I will find that somebody totally unknown to me comes to me with his son or a daughter, 15, 16-year-old son and daughter. They will somehow get to meet me and basically talk to me only one thing. Meet my son, see my daughter, how bright they are, how well they are doing in school. They want to study engineering. Get them admission in IIT, help them get the admission. Now I knew enough about JEE. Of course, I myself had done JEE. I knew that IIT there was no possibility. And I used to sort of say they have to write this exam. They said they will not get through. Then I said, well, then you have to go to other colleges. And they will say there are no colleges and we cannot get in. At that time, 82 or 83, 82 I remember doing some study, and I found that there were hardly about 100 engineering colleges around the country, having only 20,000 students. That time we are closing to 800 million population, 20,000 students. People were hungry to learn. There are no engineering colleges. And this is a time, 84 or 85, 84 probably or 85. MGR and Jayalalitha came up with a policy of private engineering colleges. Set up these private engineering colleges. IIT was huge, was fully opposed to it. Everybody used to sort of say there will be poor teacher, poor quality, it is a money making, they will take large amount of money. And it was truth also. Many of these colleges were very poor quality, money making proposition for some politicians, but there are also colleges which were attempting to teach them. Initially I was opposing that just like any other IIT, but soon realized that when we have denied these children opportunity to learn engineering, and this is providing them, is it fair on our part to oppose them? Remember, this is the time. Here the IIT ecosystem says that we should oppose them. Quality, superiority. First time started questioning all of these things. Partly my PPST background probably helped. And I had to often stand against our own colleagues and sort of say, no, you should allow them. And incidentally, what helped that children of many of the faculty who were not getting into IIT and were trying to send it to this started siding with me. What I am pointing out that this was the first time, and I was very young at that time, I stood against IIT opinion. Long run, I think it was a very, very important thing. I started talking about it. Of course, process was going on independent of me, but these large number of engineering colleges were coming up and these youngsters were getting trained. And we suddenly found that we will be able to recruit them as a project staff or MTech or things like that, and they were doing very well. They, of course, I realized by now that there were some colleges where they were getting some minimum training, not enough. But the youngsters were very bright. After all, the students who got into IIT and did not get into IIT, the mark difference was hardly anything. By now, I had figured out the whole JEE. There was hardly anything. They were very bright, they did not get the opportunity. And you provided them opportunity in your lab, initially in fiber optics communication lab, later on laser communication lab, and they will flower up. And I already had seen our MTech students who came from tier 2 colleges were doing well. And suddenly I found that, well, all you need to do is give them opportunity, push them, train them hard. You have to do a little bit of personal hand-holding, create confidence that they are doing big things, and they will become very good technologists. This was a very important lesson that I learned as early as 86, 87, 88, which I actually continued. And whether I did whatever I have done till from that time till today, that there is a law in India, the biggest strength, it is human resources. Yes, IIT is one thing, but it doesn't matter. It is very large. I was not now bothered that IIT students will go abroad. Let them, there are enough others, and all that we need to do is train them, push them hard, and they will deliver. This is something that we saw happening again and again. I'll tell you a couple of other things that happened, which actually started changing my whole mind frame, which you will see. Two incidents I remember was happening in India, other than the engineering college. You know, at that time, the only washing powder that we had in India was surf or Noon. I used to also buy that. It was expensive, so I used to buy and use it occasionally. Rest of the time, we used to use the soap. At that time, suddenly we heard of Nirma. Huge advertisement in radio, and thing that you will hear about Nirma, it is a very poor quality washing powder. It will burn your hands. Very similar to the way IIT will talk about its private engineering college. A very similar putting down this. But large number, it was very inexpensive, 1/4 the price of. And I started also occasionally using it, little care, and it cleaned. It had a little more bleaching, so it hurt a hand a bit. You have to be careful. It cleaned the clothes very well. Of course, it hurt the clothes also in long run, but how did it matter? I suddenly found that Nirma crossed the total sales on surf and became the dominant. And surf was going on opposing with all intellectuals like us supporting them. This is a quality product and that is poor quality. And suddenly we found that after some time when that nearly lost the market from dominant situation, that they came with a cheaper powder, very similar to Nirma powder. And then we realized that what India is. I learnt about India, that India is a large market for affordable product. Surf was only to service 4-5% of our population. High cost, similar to maybe the cost abroad. Only a few percentage of people will be able to afford it. But if you are able to get the product at the right price point, the market becomes very large and new industries can come up. It gave a huge impetus to me that new industries can be created only if you can make products which are affordable. Whole scenario thinking started changing. A second very similar incident took place with telecom. By that time, Rajiv Gandhi was in power, and he brought this person, Sam Petroda, from somewhere. And I remember getting invited in one meeting because I was doing enough with industry and all that. And that's a place where he was talking about why number of telephones are limited and you can't give enough phones. And making a long distance call. I remember in IIT Kanpur, in my 5 years, I made 2 calls to home. The reason, number one, I had to wait between 4 to 6 hours after booking a call to get a call. I had to wait outside the telephone exchange. You will book and you will wait outside and you will get a call. Suddenly the trunk call is now available and you can make a call. The cost of that call was equivalent to 30% of my monthly mess bill. One call. You could neither afford and you had a long waiting period. So in one of the conversations that took place in Delhi with Sam Petroda, people pointed out, yes, number of trunk lines are limited. And by the way, where we are building power line carrier communication or fiber optic multiplexing, primarily to increase the number of trunk lines between cities. That was the objective. By that time I had understood, if we can build that enough, we can, but it was expensive. And so the calls will be expensive. Till somebody pointed out that in the night time, these were hardly ever used. It was empty. And the telephones were not available. And that time in one of the meeting, basically the idea came that why can't we create this panwala telephone? We'll put a telephone at a panwala shop and people will go and make a call, pay for it. And maybe in the night time, we'll make STD calls at evening time half rate, night time quarter rates. Everybody in department was opposed, loss of revenue, this, that, same thing that you hear. Sam Petroda took the decision, I'll do that. And I remember he's asking me that, but my STD PCO machine is expensive. Can you build a low cost metering which will tell how much is the bill so that the person can pay? And I think we took up, and I remember there was one Sanjay Gupta undergraduate student, with him actually I built that. And I gave it to him. In the meantime, multiple things were built and this STD PCO started. What is very interesting, this STD PCO started and very soon it was there in every street corner. We had initially planned 10,000 of them. It became 100,000 and more, many more. This STD PCO really moved me because what I found, I myself could go there and make calls, but people used to stand in queues to make call in the evenings. They used to wait for 8 p.m. and then 11 p.m. and people will make calls. And people are very happy. And it became affordable. So I suddenly saw affordability has huge power. And this STD PCO person was actually making enough money. Initially, the government had talked about subsidy. Very soon it was forgotten. It was no longer a panwala shop, it became a STD PCO itself. And the person started selling multiple other things. The business grew. These were entrepreneurs who were growing. And we had suddenly created, I think, 1 million PCOs over the 2-3 years. We went to remote areas and created that. That area will get developed. There are enough stories that I remember going through where in a remote area this place will do. Because there is now STD PCO there, the women will be more easy, ready to come and first all the auto repair shops will come around, people will make it a taxi stand, bus stand will come, some small factories will set up, women will be more ready to come and work there because that phone provided them safety and that whole area will develop. I suddenly realized that entrepreneurship, both with Nirma and this STD PCO, is what India needs. Affordable technology is what India needs. Entrepreneurship and affordable technology will make India grow more rapidly than anything else. By this time, my dream of or thinking that politics will change things had gone. Now I have totally, particularly after that Sikh riots that took place completely shook me. And then the Bhopal gas can't, I knew politics is not the right thing. And entrepreneurship and affordable technology developed in India. Training the human strength, resources are biggest strength. Creating large human resources, engineering manpower. Training them. IIT cannot remain in its own elite structure. It has to reach out to them, work with them, masters, but project staff became very important. Train them, take up projects, do things, work with industry, transform industry. This basically was my early learning from 1981 till 86, 87. Entrepreneurship will become the best way for country's development. Affordable technology is the only way that India will develop its market. And India has large market. If the products are affordable, it can change the game. And we have to believe on our human resources. My thinking considerably changed. And but it is at this stage that I started looking at larger issues. And very fortunately, after a lot of battle within the department, I said we have to allow people to come in. 7 years, 8 years before me, nobody had come. 7 years after I came, nobody joined, or 6 years, till we pulled in, and I helped in getting Bhaskar Ramurthy. Anthony Reddy asked me to get it, and I somehow pushed it. Professor Indiresan tried his best to change IIT. This place was too conservative, would not allow him to change. That conservative trend continues even today. And is a huge difference between IIT Kanpur and IIT Madras in that. Even today, if we are not doing better than what we should, it is because of that conservatism. And one thing that I learned, that you have to fight against conservatism, you have to take risk. And whether we did wireless in local loop or where we did this, we started incubating companies, Banyan, Midas, whether we created research park or incubation cell, or our work in electric vehicles or solar DC, was always defying the tradition and doing something new. Another thing I would like to end today by stating that if you see from surface acoustic wave, I had got into digital circuits and systems, microprocessor based systems, fiber optic systems, and next was wireless. If you say, I never stayed in one area. In fact, my 8 PhD students have worked in 8 totally different areas. Everything you start from scratch and do it. This is not what IIT does. IIT to some extent does not even respect that. This whole thing that you have to publish. Yes, you have to be in one area. You have to build the ecosystem. Your whole, what is this called, H index, etc. comes from all that. Here you are jumping from one thing to another. I had made my path very clear. That I am not going to follow the tradition. And I will fight against all conservative things. And in spite of everything, I will do. IIT continues to be conservative and still becomes a bottleneck on many things.
I have questions on that. I think we will take it up about how this two models of university based education or research we can reconcile.